Myself Shakshi Kadegia, my ID number is 24CE046. I am from CSPIT C department and today we will discuss about the clock skew. So the topics we have that first, meaning of clock skew, second type of clock skew, third effect of clock skew and last one is solution for some problems due to the clock skew. So the definition is that in the digital circuits that use a clock, the clock signals controls when different part of the circuit works. Ideally, this signals should reach all the parts like flip-flop at the same time, but in real life, because of things like wire length or delays in the system, the clock signal doesn't arrive everywhere at once. This difference is called clock skew. So here we have one example of clock skew and further we have causes of clock skew that are first, wire delays. Longer interconnects can introduce propagation delays. So if we have the larger length of wire, there will be the chances of clock skew in the circuit. Second one, buffer delays. The time it takes to data transmitted after it has been stored in a buffer. So in our example, there is a clock delay which will work as a buffer delay to generate the clock skew. And below that we have the graph in which we can see the signals of clock A and clock B have the difference and this difference is known as the clock skew. Type of clock skew. First, positive clock skew. The flip-flop receives the signal later than the normal timing. Second, negative clock skew. The flip-flop receives the clock earlier than the normal timing. Third, zero clock skew. The clock signal arrives at both the source and the destination exactly at the same time. Fourth one, dynamic clock skew. Skew that varies during the operation due to the change in the voltage, temperature or switching activities. So the fourth one is generated due to the changes in the external surrounding of the circuit. And the last one is intentional clock skew. Clock skew intentionally introduced to improve the timing performance. The last one is performed because we want the betterment in the circuit by generating the clock skew by ourselves. So here we have example that the positive skew is taking time to generate the signal than more than the normal clock pulses and negative skew is generating the signal before the normal clock pulses and the zero clock skew has the same timing for clock 1 and clock 2. Further we have the effects of clock skew. First, timing violation. Clock skew can cause timing violation, potentially incorrect data captures. Second, circuit stability. Excessive clock skew can make the circuits unstable. Third one, reliability. Clock skew can cause mistakes in the circuit, especially in fast and complex designs, making it more likely to fail. So it can cause the more likely to fail situation in the complex designs. So, last one, reduce performance. Clock skew can slow down the system because it causes delays, giving less time for the logic to do its work. Further, we have the solution for the above problems. First, design clock distribution network so all paths from the clock source to flip-flops are of equal length. Second, use special software to check and fix clock timing automatically during the circuit design, like we can use CAD and that all. Third, design the circuit so it can still work correctly even if there is a small amount of clock skew. And the last one is use some advanced circuits to automatically adjust the clock signals based on the temperature and power changes. So the last one is useful for the fourth type of clock skew, that is dynamic clock skew. Further, we have the conclusion of our topic. That is, clock skew is a very small delay, just a few nanoseconds, but it can still cause big problems in the digital circuits. It's important to understand what causes it and how it affects the system. By designing carefully and using the right tools, engineer can control clock skew and make sure everything in the circuit works together smoothly. Thank you.